Here's a little assistance on one of your homework problems. This is number 36 on page 48. It's one of those graphs that is a little bit difficult to interpret the solution. Again, this is a system. I've just separated the equations out so I can show my work solving for y and other things that we're going to need to sketch each of these lines. And if there is a solution, and if there's just one solution, it will be where these two lines cross each other, their point of intersection. And sometimes that's not very easy to tell. So I'm going to work through this and then hopefully this will help in other cases like this when this appears. So let's go up to this top equation of the system and solve it for y, adding 3x to both sides, and we get y is equal to 3x minus 29. Okay, and then we'll jump down here and do the same thing for the red. Let's solve it for y. So we're going to subtract 9x from both sides, and then we're going to divide by -6 on both sides, and -9 divided by -6 is positive 3/2 x, and 102 divided by -6 of course is -17. Okay, so right away we can see we got a little bit of an issue of showing the y-intercepts on our graph if we're going to start with y-intercepts and counting slope. So let's just change our units, and then we can make these fit pretty easily. So for example, I'm going to choose to do units of 3. You can do 3s for both the x and the y. Okay, and it's going to cut it really close on this one, but it's okay. I think I used the same graph paper you have on your homework, so it would make a little bit more sense when you do this. So let's see, this would be 9 marks, I believe, and this is the 10th one. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's -27. This would be -30. So we're going to make a mark right above that very bottom part of the y-axis to say that that's -29. Okay, and we're going to count a slope of +3. Okay, so remember this is 2 right now, so if we go up to this line, that's 2, or this is 29, so this would be 2, and then one more. We'll estimate this to be 3. Okay, and as you remember from our discussion this morning, that gets a little tough. If these are in 3s, then how far do we go for 1? And you can guesstimate, but what I like to do in cases like this is just think of this as another number that maybe will help us count out 3. I'm not saying you have to do this, but it's something to think about if you want an easier way maybe to count these out. So for example, I could represent 3 as 9/3. Let's see if that's any easier. We said earlier that this is 2. Okay, and then one more makes 3, and then up here's another 3, that's 6. Another 3 is 9, and then right one whole is 3. Okay, so you see how that worked, and we're still guesstimating, but to me I feel a little bit better than trying to figure out where 1 is. It's going to be pretty close either way, but it's just a suggestion. I'm going to do that again. So 3, 6, 9, and then over 1, and let's just go ahead and connect those dots to show this line y equals 3x minus 29. Let's see if I can line those up. That's pretty good, I guess. Okay, so that's our line for this top part, and now let's I should have switched the colors, but let me just label the lines so you'll know which one I'm dealing with. So what I just did in red is this linear equation. This is y equals 3x minus 29. Okay, so maybe I'll do this one in blue. How's that? Let's just start this one in blue. Okay, so again, solving it, we get 9x plus 102, and then 3/2 x minus 17. Okay, so negative 17, 3, 6, 9, 12, 15. This is 18. So I'm going to say negative 17 is right there. Now this time, instead of counting slope, I'm going to do it a little differently. I'm going to find the X-intercept like I did in class. Alright, so that just means let y be 0 and solve for x. Sometimes this is useful. Okay, just another way of doing it. Multiply by 2/3 on both sides, and you get 34 thirds on the left side is equal to x, and 34 thirds, you can think of that as 11 1/3. Alright, so let's see if we can find 11 1/3. That's 3, 6, 9. This would be 12. So 11 1/3 I'm going to guesstimate as right there. And I'm just going to, with graphing intercepts, I'm just going to connect those two intercepts. Okay, so I'll try to line those up and see what that looks like. That's not good, so let me try that again. It's not always easy with my board to line these points up. I'm not real satisfied with that, so okay, I think I got it. Had to take a couple of runs at it, but I think I'm good. So my blue line, I used the intercept method. I found the Y-intercept. That's pretty easy. Then connect that with the X-intercept and just connect those dots. And then we used a different way to do the red line. So can we tell where these two intersect? Well, not exactly. This is where I'm going to need another method to give me some confidence. Now, if this were a graphing calculator, I would know exactly. But unfortunately, we don't have a graphing calculator. So we're going to use the tried and true either substitution or elimination. And since I used elimination in my class example, let's use substitution for this one. So since these are already solved for y, I solved them for y for the sake of graphing, then substitution says since y is equal to 3/2 x minus 17, then I can replace the y up here with 3/2 x minus 17. Or I could go the other way. I could let 3x minus 29 replace the y down here. It really doesn't matter. I'm just going to say 3x minus 29 will replace this y. Okay, that's just the substitution method. 3x minus 29 is equal to 3/2 x minus 17. And we're going to solve for x. Okay, so just think of this as 6/2, 6 over 2x, that's 3. 6/2 minus 3/2, because we're going to subtract 3/2 x, and that is 3/2 x. And then we're going to need to add 29 to both sides, so hopefully you can see this without me showing the steps. Adding 29 to both sides gives me 12. Multiplying both sides by the inverse of 3/2, it's 2/3. That's going to give me x is equal to 24 thirds, which is 8. So let's just see if that's reasonable to think that x could be 8 based on my graph. Well, this is 9. And yeah, we're really right on it. 8 should be really close, just to the left of 9. So we're looking good. The x-coordinate of that point of intersection will be 8. And now let's find the y. And we can plug into either one of these. Looks like this one would be easier. If I let x be 8, I get 24 minus 29, and that's negative 5. Okay, so the y coordinate of this point of intersection I'm getting as -5. Does that look reasonable? It certainly does, because coming down from 8, that would be -3, and that could be, it's pretty close to, it might be a little high, but there again, that's the shortcoming of the graphing method when we're doing them by hand like this. When we can't tell exactly where they're crossing, then we rely on other methods to give us an exact point of intersection. So the final solution for number 36 should be x is 8 and y is -5. So I hope that helps you, and if you have any other questions, feel free to email me or come in academic support.